Hey guys, Zong here, back with another math video. I am sorry for the late video. This week was finals week for high schools in my region, so I was busy with finals. But nonetheless, I'm back, and today I'm going to be doing a video on this Saturday morning breakfast cereal comic. And I thought it was really interesting because I saw this in my newsfeed and I decided to do a video on it. The video is going to be on the last panel where this woman says, "The harmonic series grows to infinity unless you throw out numbers with a 9 in their denominator." And I thought that was really interesting. So the harmonic series, if you don't know, is I think it's this, which does not converge. It goes to infinity. So it would just be 1 over 1. So 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 dot dot dot. That goes to infinity. And so yeah, the question is, if you take out all numbers with a 9 in their denominator, with a digit 9 in their denominator, they'll actually converge. And the question is how to prove that. So try to prove it on your own. I don't think it's it requires knowledge that's too complex. I think you can do it. Pause if you need to, and without further ado, we're going to try to prove it right now. Okay, so let's assume that the denominator has n number of digits, and that's probably bad because I already used the number n, but to use this. So let's say there are n digits in the denominator. Okay. How many numbers are there of n such that 9 is not in the denominator? Well, if 9 is not in the denominator, then for the first number you can choose any number 1, 2, 3, 4, 5, 6, 7, 8, and so there's 8 possibilities for this number, times 0, 1, 2, 3, 4, 5, 6, 7, 8, so that's 9, times 9, times 9, times 9, and that's going to be n minus 1 nines. So the number of numbers n digits long without the digit 9 is going to be 8 times 9 to the n minus 1. And that's the number of numbers that are n digits long without the number 9. So it's important to note that, let's say this number is equal to x. Let's denote this number as x. X has n digits long. X is going to be greater than or equal to 10 to the n minus 1 unless they're equal to 10 to the n. Obviously, because x has n digits, so it is an n digit number, and 10 to the n minus 1 is the smallest number with n digits, and 10 to the n is the smallest number with n plus 1 digits, so x must lie in between those numbers. But now let's take the reciprocal of just these two. If we take the reciprocal of this, we have to switch the greater than the less than greater than sign, and we realize that 1 over x is less than or equal to 1 over 10 to the n minus 1. And why do we switch the sign? It's because x is greater than 10 to the n minus 1. So now 1 over x is a greater denominator, resulting in it being smaller than 1 over 10 to the n minus 1. Right? And this applies for all numbers of n length. And we know that there are 8 times 9 to the n minus 1 numbers of n length. So let's just multiply both sides by 8 times 9 to the n minus 1. So 8 times 9 to the n minus 1 over x is less than or equal to 1 over 10. 8 times 9 to the n minus 1 over 10 to the n minus 1, which is equal to the sum of all fractions with denominator of n digits without 9. So we're going to assume that that x, so let's let x be a certain number of n digits, and since 1 of x is less than 1 over n minus 1, we know that the summation of all possible values of x, 8 times 9 to the n minus 1 values, is going to be less than 8 times 9 to the n minus 1 over 10 times n to the n minus 1. Yeah. So now, so we know that. Now let's have it apply for all of n. So the sum of all fractions with numerator 1 without 9 in denominator is going to be equal to n equals 1 to infinity, because it starts at 1-digit numbers and goes to infinity, of 8 times 9 to n minus 1 over x, which is less than or equal to n equals 1 to the infinity of 8 times 9/10 n minus 1. We just simplified it, actually. We just took out the 9/10 n minus 1, so it's the same. And that's equal to 8 times n equals 1 to the infinity, 9/10 to the n minus 1. And what is this? If you don't know how to calculate that, we can calculate it by hand, actually. So this value is just going to be, so n equals 1, starts at n equals 1, n minus 1 is 0, so it's going to be at 1 plus 9/10 plus 81 over 100, dot, dot, dot. Let's let that be equal to k. Okay. Now let's multiply every term of k by 9/10. 9/10 plus 81 over 100 plus 273. Oh, no, it's not. 729 over 1000, dot, 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 equals 9/10 k. If we subtract the top from the bottom, we get 1 equals 1/10 k. K equals 10. So if this is k, that means this is equal to 8 times 10, which is 80. It looks like this converges. So what this results in is that this is getting really messy, is that this value right here is less than or equal to 80. So the sum of all fractions with numerator of 1 without 9 in the denominator is less than or equal to 80. So we've proven that it doesn't go to infinity, and we've proven that a harmonic series without the numbers 9 in their denominator actually converges. And this applies to actually not only 9, but any number or sequence of numbers in the denominator. You could take out numbers in the denominator with just 42 in the denominator, and it would still converge. Or 849, that sequence of numbers, you take out all numbers of that sequence of numbers in the denominator, and it would still converge. If you take out any numbers with a certain sequence of digits in the denominator from the harmonic series, it will converge, and that's called the Kempner series. So I think I spelled it right. I hope I did. He's the one who proved this. And interestingly enough, he calculated really close the real value that it converges to. So let's. I need a bigger eraser. So actually, he calculated like pretty close. The number actually converges to 22.9206766, which is definitely less than or equal to 80. So I just thought that was interesting. Hope you liked it too. I'll see you next week. Oh, the audio